Hi guys, in the previous video we have seen how to create a memory dump file, how to change the settings in order to save that generated dump file when we manually crash the system into the disk. Now in this video we're going to analyze that generated memory dump file in the previous video by using a tool called Volatility. Volatility is an open source tool. It's a Python framework which is used to analyze the memory dump file, which can be analyzed for various things. So for to analyze a memory dump file, we have created a memory dump file like in the previous video. So this is the memory dump file we're gonna analyze in this video. So the other files are volatility framework setup. You can find it in this URL www.volatilityfoundation.org. Go to the releases and download any version that suits with your compatibility. So you can find many other versions too. Okay, so now we're gonna see some commands which volatility supports. So in this GitHub link, you can find all the command references. And for example, image info is the first command we're gonna see today. So if you click on image info, you can find a command for that. So this is using the Python program as it is, but we have the standalone application, so we're gonna use this. So I'm gonna show you a few things. So this is the execution window of the first command, that is image info. Image info, it generates the profile information of that memory dump file. As you can see, the profile information is here. It basically gives the details of what the system is when that memory dump file is generated. So that can be used in other commands, like if you see the profile information we have passed for ps list, that's process list, process tree, dll list, dll dump, memory map, memory dump, and all. So this is a pretty helpful command, and it's one of the first commands we're going to try because we need the profile information to proceed to the next command. If we don't know the profile information, if the source of that memory dump file is unknown, then this command is pretty useful. So next command we're going to see is ps list. It generates the process list of a tree. So it takes time for like to pull all the processes that are in that memory dump file. It's actually it lists all the processes of the system that were running when the system was crashed. And ps list also shows the session id, offset address, and the name of the processes and the process id when it was created and all. So this is a pretty helpful tool. And ps tree is a data structure, like it displays this information using a tree. uh, you can see in that, but just wait. It ps scan, sorry, yeah, ps tree lists all the processes in a tree format. We also have another command, that is ps scan. By using ps list, you cannot pull the hidden processes. There are some processes that are hidden in the memory dump file. For example, malware.exe. You cannot find malware.exe here. So it's an hidden process that you can pull from ps scan. That's the only use of ps scan. So this could take for a while. We'll see next commands and then we'll come back to the output of this. So next we're gonna see is DLL list. You know the importance of DLL files in a system. If there is a way to list all the DLL files that are all in the memory, then it can be a pretty good one. It can be a pretty useful command. So the command started and the list goes and goes on and on and on. So I'm just gonna explain that. So we'll get the base address, the size of the DLL, the load count of the DLL, and the path of the DLL. And this is the DLL name. So these are all the DLL files we're gonna generate. I have interrupted that just to show you the output. What if we want to pull all these DLL files and save it in a hard disk? So for that we can use DLL dump. DLL dump basically has an additional argument that you have to pass, that is the DLL dump directory. This is the location on your hard disk where you want to save all these DLL files that are generated. So I'm gonna show you that. So this is a dump directory which I have specified in the command. Here the folder is empty right now, so I'm gonna pull all the DLL files here and just save it. This could take a long time because there are many DLL files in this memory dump. So I'm gonna put this aside and we'll just move on to the next command. The next command is memory map. Memory map command shows you the virtual address of the page, the corresponding physical offset of the page. So I'm just gonna execute it. The page and also the size of the page. It's an helpful one. Let's see how many we got here. Oh, this is the DLL one. It didn't even start till now. Yeah, it's gonna start now. See, this is the tree data structure that I was talking about the PS tree. It is all the processes that were active, and it is represented in a tree based on the active time. So these are all the DLL files that are saved till now. Let me just head back to the dump directory and show you. See, so it will go on and on till all the DLL files are stored here. So moving on to the memory maps output. This is the memory maps output. I'm just gonna interrupt it because it's a long list of the output. You can't even see that. So this is the virtual address, this is the physical address, the offset, and the size. Okay, so what if we want to save all this information, all these files in a disk? So for that we have memory dump. So similar to the DLL dump, we should specify a directory for this too. So that is v files. I'm gonna head back and show you where the v files directory is. So v files, it's empty in the beginning. So after this command is done working it will probably pull up some data so that we can visualize what's really happening there. So in meanwhile, let's move on to the next command. Okay, this is connections. Okay, I'll use another terminal for this. Yeah, connections is a plugin which lets you view all the TCP connections that were active at the time of the memory dump, at the time when system was crashed. So this is a useful tool too. See the offset of the connection, the local address, the remote address, the process ID, and all. Now moving on to our last command, the MFT parser. The MFT parser scans all the MFT records that are available in the memory dump and displays each info about each file, such as creation date, modified date, altered date, access date, and time of that process. Like I'm gonna show you here, MFT parser. Yeah, MFT parser. So you can find like information about each command in this page, in this GitHub link, and you can even have an example output too. So this is pretty cool page, so you can just visualize what's happening here. That's all. These are the commands that we tried. Thank you for being such a wonderful audience. Bye bye.